Hey everyone, welcome back to the channel. Today we are diving into something super relevant if you are in voice tech or you are in AI agents or want to build something that listens and talk back conversational voice agents. What are they, how they work, how much they cost, and most importantly, how you can save a lot of money if you build a custom streaming based agent rather than using big APIs all the time. By the end of this video, you will know what conversational voice agents are, how streaming and these systems works, what is the pricing of this conversational AI agents if you use any external platforms like Vapi, uh, ElevenLabs. So we are going to take an example and then I'll show you how it costs, and also I'll show you if you do it yourself as a custom solution by using FastRTC library, how can you save the cost? If you like this topic, hit like, subscribe, and let's jump into the topic. Uh, yeah, guys. So today's agenda is very simple. First, we are going to understand what are conversational voice agents. Then we will discuss what is the architecture behind of building the conversational voice agents. Then we will see cost comparison deep dive, as I mentioned earlier, with external platforms like Vapi and ElevenLabs. And also we will see how you can optimize the production cost if you build yourself using open source libraries like FastRTC and etc. Right. So before understand what is conversational voice agents, right? You might have seen a lot of chatbots in recent time. So almost every organization is adapting these chatbots, right? Chatbot is nothing but like you will come to the chat system, you will type the message and send it to the system, and system generates the output based on your question, and then it will reply back to you, right? So there is a problem in this, right? Because every time user wants to get some information, he has to gone through the typing, right? Which obviously irritates the user, right? So to solve this, what we are going to build is, instead of writing a query and getting the response from the system, we will directly talk to the system like how you were normally talking with a human being, right? So these are called conversational voice agents, where you are giving voice as an input and as well as you are getting voice as an output, right? So let's jump into the technical architecture of this analysis, how it works. So let me take you to the drawing pad. Before discussing conversational voice agent architecture, I just want to remind you how traditional chatbots works. In the traditional chatbots, you will give the input to the system and system processes your input, and then it will generate the text as an output, and it will come to your chat system, right? Conversational voice agents architecture uh, differs little bit. What will happen? First, user speaks, right? When user is speaking, we need to capture audio, correct? We need to capture audio. Once you capture the audio, you need to transfer that audio to speech to text model. So STT is nothing but speech to text model. What it does is, speech to text model, what it does, it takes audio as an input and then it will convert to the text, right? So once it converts to the text, we are passing back to the LLM. So here LLM receives text, user text, along with system prompt as an input, correct? Once LLM receives the input, and then LLM generates text as an output. It will generate text as an output. Once LLM generates the text, that text has to go to text to speech model, TTS model. What is this? Text to speech model. Text to speech model. So why we need text to speech model? Because your LLM is generating text as an output, and then you are converting that text back to the audio files, right? So once TTS process is done, it will give you audio as an output. Audio as an output. Once you get the audio output, you have to play that audio in the browser or mobile application, whichever user interface you are using. Right. So simply to simplify one more time, user speaks, we need to capture audio of the user, then we need to convert that speech audio to the text and then pass the text to the LLM. Then LLM process and generates the output. Then once LLM generates the output, you have to pass it to text to speech model. Once you pass text as an input to the TTS, TTS will give you audio as an output. That audio you need to play to the user. So this is how a conversational voice agents works. But there is a catch. So whatever this pipeline we are building, audio to text, again text input to text output, and as well as text output to audio, so text input to audio output. Correct. All these should work in real time. All this should work in real time. It means you need to stream everything, right? Right from the user. Once user starts speaking, you need to send audio chunks to the speech to text model. Then it will contact it to LLM, and then LLM will be giving streaming output to the TTS, and also TTS gives you streaming output. Then you have to play audio as a chunk by chunk, so that user feels like it is conversational. If you wait till user speaks and then pass it to speech to text model, obviously it will take time to convert to the text, and then LLM takes time to generate the output, and then again if LLM generates an output, if it goes back to TTS, and then TTS takes some more time to convert from text to audio, right? So to avoid this delay, what we have to do is we have to use streaming option. We have to use streaming option, right? Let's jumping into the code, how we are doing, how we are constructing this pipeline. I just want to discuss about casting part. As we discussed earlier, let us continue to our presentation. So right, so we have discussed what is speech to text does, and what is language model does, and as well as what is text to speech does, right? So so if you see the cost for the ElevenLabs solution, so let's say an average business use case, if you get 5 hours daily uses, which means 9,000 minutes in a month. Let's say your usage is 9,000 minutes in a month. Then for ElevenLabs, they are charging 0.50 rupees for the speech to text model per minute cost. This is, and as well as for LLM cost, it will be 0.83 rupees per minute. So, and as well as TTS means text to speech model will cost you 6.64 rupees per minute, which is very huge, right? So if you calculate per minute, it costs you around almost 7 rupees per minute, right? So accordingly, you can calculate if you use 5 hours daily or 2 hours daily, how many minutes you can use. Into 7 rupees, if you do, then your ElevenLabs platform cost you will derive. Uh, Other hand, you have a Vapi platform. So Vapi is also gives you almost 4 to 5 rupees, 4 to 5.5 rupees per minute, which is also very huge, I feel, because see, if it is for 30 minutes per day or 50 minutes per day, then obviously you can choose third party platforms, because 30 minutes per day is not a big deal. So but when your usage is more, your usage is 8 hours per day, or 10 hours per day, or 12 hours per day, then your bills are doubles, right? So let's say for 5 hours you are getting 38,000 almost here, right? So instead of having 38,000 rupees to the Vapi platform, you can hire a customer support, right? Who will, who will handle the customers, right? So to avoid all these costing problems, so we can build our own, solutions using FastRTC, right? See, you can see here, this is the 11 labs charge for 5 hours per day. I take it as input. Then this is the Vapi platform, and this is the custom FastRTC, our solution cost. Right. This is for 5 hours. If your usage increase to 8 hours, and if you say if your usage is more than 10 hours, then obviously Vapi cost also will be more, and your FastRTC solution will be much more cheaper, right? Right. So what advantage you will get over this platform if you build yourself, right? First one is complete control, because STT model and LLM and TTS all are in your hand, right? Whatever customizations are required, you can obviously do what any customization whatever you need, right? And then second thing is, these since these are open source models, you no need to pay per minute API fees. In earlier cases we have seen, for each text to speech and speech to text things, every time you need to pay for their APIs, right? And we are going to use FastRTC library for this, so which is also a free open source. So in the end, if you go for a custom solution, you just need to manage your infrastructure cost and as well as development costs. So these are the advantages. When it comes to the disadvantages parts, right? So you need to maintain your own cloud, right? If you take third party platforms like ElevenLabs or Vapi platform, uh, uh, all cloud services will be maintained by them, so you will get rid of headache, right? So coming to the custom solution, since you are hosting all these models, and then you have to take care of your cloud services, right? So which one we need to choose? What is the right architecture to be chosen, right? So you have to go for ElevenLabs or Vapi when your development is critical. Let's say you don't have any development team with you, then obviously ElevenLabs and Vapi platform is the best choice for you, because they give pre-built solutions. You just need to give the prompts and build. So there is much technical knowledge is required to build ElevenLabs agent or Vapi agent, right? Your usage patterns are low or intermittent, means like earlier we have discussed, if your usage is very low, let's say half an hour per day or 2 hours per day, then obviously ElevenLabs or Vapi will be the right choice for you. Then one more advantage, when you are looking for a premium text to speech quality without any infrastructure overhead. If you don't want to take any infrastructure overhead, then obviously ElevenLabs or Vapi will be the better choice. Then like as we discussed earlier, if you have a limited technical resources for self hosting, then you need to opt for ElevenLabs or Vapi, right? Then when you have to go for a custom solution, you have high volume production usage, right? In a day, your usage is more than 8 hours or more than 10 hours, then obviously custom solution will be the right choice for you, since here, because you will do a lot of optimization, right? So when you have a flexibility with speech to text, you can have you can select your own speech to text or text to speech open source model. So then you have a technical expertise available, like let's say you have a development team, then obviously a custom solution will be the right fit for you, right? So, this is about the presentation. Now let's go into demo. First, let's see how to build this custom voice agent, and then we will jump into the demo, right? Yes, guys. So this is my demo code. First, let me show you what I have done. Then I will walk you through the code. So what I have done is, first you need to create a virtual environment, which is a regular exercise for any project, right? You have to use Python -m virtual environment you have to create. After creating a virtual environment, you have to activate that virtual environment, right? Once you activated a virtual environment, then what you have to do, you need to install FastRTC. FastRTC comes with several modules, right? So I'm not installing all the modules because it is a huge library. So what I am doing is I'm taking separate components for STT, TTS, and then a VAD. So STT you already know, speech to text, and TTS is for text to speech, and VAD is advanced. VAD is a component which is used to detect the voice. So generally they call advanced voice detection. So when user wants to speak, right, that time you need to capture his audio. That time VAD will be useful, right? And then regular libraries, other two more regular libraries I have used. One is python.env, which is used to load the environment file, and then I have used OpenAI for my LLM communication, right? So now I'll go through the code. So here you can see that along with this I have used NumPy also. Apart from this I have used NumPy also, because audio will be converting to the n dimensional array, right? So for that we need a NumPy library, right? So yeah, you can see my imports. My imports are very simple. First I'm importing Gradio. Gradio is inbuilt UI library which is given by FastRTC itself. So it is included in FastRTC library. Then we are importing NumPy. Why NumPy? Because when we are converting when we are dealing audio chunks, right, we will generally get in n dimensional array. For to process those n dimensional array, we need NumPy library, and then we are using .env to load our environment file. And then from FastRTC we have using couple of things. One is for STT model, TTS model, so, and stream service, right? And then additional outputs if required we can use, and then reply and pause components, right? So after this we are importing OpenAI for LLM communication, right? So you can see that inside my env I have declared OpenAI API key, so which will be used in our program, right? So first I am loading my environment file. After loading environment file, I am loading speech to text model and text to speech model. So you just need to write two lines of code to import those two models. So by default, speech to text, it will import Moonshine speech to text model, Moonshine STT model. For TTS it will import Kokoro TTS model. So these are the default models FastRTC is using. So if you want to integrate other libraries, they have a beautiful documentation where you can go and select if you want to use any other models. Then I'm using OpenAI here. So this is the code, the OpenAI, this is the prompt I have given for the OpenAI. So I have given character name, your Nancy, a friendly and helpful assistant for the YouTube channel, which is my YouTube channel, Auto AI Learners. And this channel creator is Naresh Kumar from Bangalore. Right. After that, greet viewers warmly and answer. So this is the regular, prompt. So I have told them if any user come and ask you about artificial intelligence or machine learning, then only answer them. If they asked any other topic, then politely respond, I'm sorry, I can only answer about these questions. So that's it. The my prompt, nothing else, right? So once everything done, you have to define the stream. Once you define the stream, then you can launch the system, right? So how it works, we have already discussed the architecture. First, it will capture the audio chunks from the user. Then those audio chunks passed will be passed to the speech to text model. Then speech to text model will generate the text. Text will go to LLM model. So LLM will generate the text output, and then text output will go to the text to speech model, which is Kokoro model we are using here. Uh, Once it goes to Kokoro model, what Kokoro model does, Kokoro will convert from text to speech, right? So once, as soon as it is converting the speech, and then FastRTC will be stream back these audio chunks to the browser, so that browser will play this audio, right? So without any delay, let's go and see the demo, right? So let me run this program first. So you have to run same, since my file name is main.py, I'm running Python, my file name main.py. So it will take some time, guys, because it has to load two open source models, as we already discussed, which is a moonshine model, and as well as Kokoro model, right? So since my laptop is running on CPU, it takes bit time, because I am only using CPU based laptop. I don't have GPU access right now. So maybe later stage, I will try to show the similar demo in GPU cloud. Uh, right, so that system will be much faster. And also right now I have used default models, which is supporting by FastRTC, but later stage we will use much efficient models, so that your output will be much more efficient. And also here I am not using any tools for the LLM access, right? So let's say this is a general purpose conversational voice agents, which will only answer for AI ML questions, right? But in the future I will do the same thing. Like, let's say we can build something like a conversational voice agent for a restaurant, right? In the restaurant, what will be there? Generally menu will be there, prices will be there, and their special dishes will be there. And as well as users can call and ask the system to reserve a table, right? So for this we need to use external tools, because LLM will not be having access for that particular restaurant information. So later, maybe in later stage, I will try to integrate the tools, and I will try to build a complete solution for restaurant, or we can build a complete solution for the e-commerce platform, right? In the e-commerce also, it is a right use case, because users will be tracking their orders. User, wants to take product suggestions, right? So currently, I think Amazon is already launched their Rufus AI, where you can just send your voice note. It will give you the product suggestions, right? So which is very good use case. You can also build similar kind of conversational agents using fast RTC, right? So my program is running. You can see that it is running at port 7860. Let me quickly go through that port and then show you the demo, right? So this is how user interface looks like. Once you come to the browser, you have to give the microphone permission. After giving microphone permission, you have to click on record. Then we can talk to the system.
Hey there, how are you doing?
Hello, I'm great. Thank you for asking.
Can you explain me about machine learning algorithms?
Machine learning algorithms, also known as meta learning, focus on understanding how to learn efficiently across different tasks or environments. These algorithms aim to improve a model's ability to generalize and adapt quickly to new tasks by learning from past experiences. If you're interested in optimizing learning strategies and achieving better performances across various tasks, meta learning algorithms are the way to go.
Who is the Prime Minister of India?
I'm sorry, I can only answer questions about AI and ML.
Can you explain me what is artificial intelligence?
Of course, artificial intelligence, AI, refers to the simulation of human intelligence processes by machines, such as learning, reasoning, and self correction. AI enables machines to perform tasks that typically require human intelligence, like speech recognition, decision making, visual perception, and language translation.
Thank you so much. Have a nice day.
You have a wonderful day too.
I hope you enjoyed the demo. If you really like the demo, please like, comment, and share. And don't forget to subscribe. We'll meet in the next video. Thank you so much for watching.